Hello friends, in my first video I have explained all the definition, short examples and up to the question number 1 to 4. Now in this video we will start all the remaining questions. Now let us start. Now here is the question number 5. Find the probability distribution of number of success in two tosses of a die where success is defined as number greater than 4 appears on at least one die. Its solution: when a die is tossed twice, the sample space S has 6 into 6, that is equals to 36 sample points. Therefore, n of x is equals to 36. Trial will be a success if the number on at least one die is 5 or 6. Let x denotes the number of dice on which 5 or 6 appears. Then x can take the values 0, 1, 2. When x is equals to 0, that is 5 or 6 do not appear on it. Any of the dice, then any of the dice, that is no 5 or the 6. Then what is that sample space? That is capital X is equals to 1, 1, 1, 2, 1, 3, 1, 4, 1, 2, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4. And therefore, the n of x is equals to 16. Then what is its probability? That is a no number on that to both the die, that is a less than 4. Therefore, n of x upon n of s is equals to 16 upon 36, and that is equals to 4 upon 9. That is when x is equals to 1. That is at least 5 or 6 appears on exactly on one dice. Then the sample space x is equals to, it's a random variable, 1 5, 1 6, 2 5, 2 6, 3 5, 3 6, 4 5, 4 6, 4 1, 4, sorry, 5 1, 5 2, 5 3, 5 4, 6 1, 6 2, 6 3, 6 4. Therefore, n of x is equals to 16. And hence, the probability when x is equals to 1, that is, one die has a number greater than 4. N of x upon n of s, and that is equals to 16 upon 36, and that is equals to 4 upon 9. When x is equals to 2, that is a 5 or 6 appear on both of the dice. That is, x is equals to, that is a 5 5, 5 6, 6 5, and the last is 6 6. Therefore, n of x is equals to 4. Therefore, probability of x is equals to 2. That is, the both of die has a number greater than 4. N of x upon n of s. That is 4 upon 36, and that's equals to 1 upon 9. The required probability distribution is P of capital X is equals to small x, which is 0, 1, 2, and its probability is 4 upon 9, which is the first one. 4 upon 9, second is 4 upon 9, and third is 1 upon 9. Okay. Now the next example. From a lot of 30 bulbs, which includes 6 are defectives, a sample of 4 bulbs is drawn at random with replacement. Find the probability distribution of the number of defective bulbs. Okay. Now the solution. Here the number of defective bulbs is the random variable. Okay. Let the number of defective bulbs is denoted by capital X. And x takes the values 0 defective, 1 defective, 2 defective, 3 defective, 4 defective. Actually, there are the 6 defective, but we are drawing only the 4. Since the draws are done with the replacement, therefore the 4 draws are independent experiment. The total number of the bulbs is 30, which includes 6 are defective. Now for the first 0 defective. Therefore, P of 0 is equals to P all non-defective bulbs, and therefore it's a probability. Non-defective is 24 and total are 30. 24 upon 30, 24 upon 30, 24 upon 30, 24 upon 30 into. Okay. Therefore, you will get that is a 256 upon 625. You can perform its calculation. That is the first is next is a P of capital X is equals to 1. That is 1 defective and 3 are non-defective. Then what are their possibilities? The first is 1 defective means 6 are defective, 6 upon 30 into non-defective 24 upon 30 into 24 upon 30 into 24 upon 30 plus. Now first is again non-defective, second is defective, third is non-defective and fourth is non-defective plus. Next possibility is first, second non-defective, third is defective and fourth is non-defective. And for the last non-defective, non-defective, non-defective and this is the again the defective. Okay, in this way if you perform their calculation and then again you will get P of 1 is equals to 256 upon 625. Next, when capital X is equals to 2, that is P of 2 that is a 2 defective and 2 are non-defective. 2 defective means what? That is a, then again you will get that is a 6 upon 36 into 6 upon 36. These are the 2 defective. The remaining 2 are non-defective and therefore we can write here that is a 24 upon 30 into 24 upon 30. Next, we can perform this when this is the again 24 upon 30 is a non-defective, this is defective and non-defective. Again plus 24 upon 30 into 24 upon 30 into 6 upon 30 into 6 upon 30. These are the defective and in this way you will get all the possible combinations. Okay, and overall you will get their sum is 96 upon 625. Therefore, here the last is a next is a 2 defective and the P of capital X is equals to 3. That is a 3 are the defective and 1 is a non-defective. 3 are defective means what? 6 upon 30 into 6 upon 30 into 6 upon 30 into 1 is non-defective means what? 24 upon 30 plus again 6 upon 30 into 6 upon 30 into 24 upon 30 into 6 upon 30 plus again 6 upon 30 that is a defective into non-defective, defective into defective. Again, these are the combination, you can perform this combination. And overall, after the calculation, you will get 16 upon 625. Next, P of capital X is equals to 4. That is, all are the defectives. Then what are their probabilities? That is a 6 upon 30 into 6 upon 30 into 6 upon 30 into 6 upon 30. And in this way, after their calculations, you will get 1 upon 625. Therefore, the required probability distribution is, what is that? Capital X is equals to X. That is a 0 defective, 1 defective, 2 defective, 3 defective, 4 defective. And their corresponding probabilities are here. That is a 0 defective, 256 upon 625. 256 upon 625. 96 upon 625. 16 upon 625. 1 upon 625. A coin is based so that the head is 3 times as likely to occur as a tail. If the coin is tossed twice, find the probability distribution of the number of the tails. Okay. In most problem, we consider the coin is unbased, but here is a coin is the based. And here, that is a head is a 3 times as likely to occur as a tail. Okay. Given a based coin such that head is 3 times likely as a tail. Therefore, P of H is equals to 3 by 4 and P of T, the probability for the tail is 1 by 4. A coin is tossed twice. X can be random variable for the number of the tails. Therefore, X can take the values 0, 1, 2. Okay, X can be the random variable for the number of the tails. And there the values are 0, 1, 2. Therefore, in 2 tosses, that is a 0 tail, that is a both of time, there is a head and head. Therefore, their probabilities are 3 by 4 into 3 by 4. And that's equals to 9 upon 16. That is the P of capital X is equals to 1. Then, what are the possibilities? That is the P of HT and the TH. That is you will get, that is equals to 3 by 4 into 1 by 4 plus 1 by 4 into 3 by 4, their respective probabilities. And after calculation, you will get 6 upon 16 and that is equals to 3 upon 8. When there are the two tails, then the probability of TT is 1 by 4 into 1 by 4, and that is equals to 1 upon 16. Therefore, the required probability distribution is the values of x, that is the number of the tails 0, 1, 2, and their respective probabilities. 0 tail 9 by 16, 1 tail 3 by 8, and the 2 tails 1 upon 16. Next problem. A random variable capital X has the following probability distribution. The values of X random variable, its values are 0, 1, 2, 3 up to the 7, and their respective probabilities. Determine K. Second, probability of capital X less than 3 and probability of capital X greater than 4. Since the P of X is the probability distribution of X and their sum, that is here I is equals to 1 to n, that is up to the 1 to 7, and their probability, sum of their probability, that is equals to 1, that is P of 0 plus P of 1 plus P of 2, P of 3, P of 4, P of 5, P of 6, P of 7. What is the value of P of 0? The value of P of 0 is 0. P of 1 is K, P of 2 is K, P of 3 is 2K. And in this way, substitute all the values. And that's equals to 1. And if you count it, if you simplify this, then you will get 10k square plus 9k minus 1 is equals to 0. And therefore, this is the quadratic equation. And the product of 10k square and minus 1 is a minus 10k square. Then what are the two numbers whose product is a minus 10k square and the sum is 9k? Therefore, 10k square plus 10k minus 1 is equals to 0. Now take the 10k as a common, then in bracket you will get k plus 1. Take the minus sign, minus 1 in bracket k plus 1, that's equals to 0. Take k plus 1 as a common and then in next bracket 10k minus 1, that's equals to 0. And therefore 10k minus 1 is equals to 0. Therefore k is equals to 1 upon 10. Next, probability, that is the P of x less than 3. Then what are the probabilities? That is the P of 0 plus P of 1 plus P of 2. And what is the value of P of 0? Is 0. P of 1 is k. P of 2 is a k. 2k, sorry. And what is their sum? Is a 3k. That is a 3 into 1 upon 10. That is equals to 3 by 10. And hence, P of capital X is less than 3 is a 3 by 10. And this is the probability. Next, P of capital X is greater than 4. Then what are the probabilities? That is the P of 5 plus P of 6 plus P of 7. Therefore, and their respective probability. That is what is the P of 5? Here, the P of 5 is a k square. And P of, okay, here is a P of 5, P of 6 and the P of 7. And in this way, after substituting P of 6, see this is P of 6, that is a 2k square, and P of 7 is a 7k square plus k. Okay, all these are here for the first, second, and this is the third one. Okay, and their sum is a 10k square plus k. And if you substitute the value of k, which is 1 upon 10, that is a 10 into 1 upon 10 bracket square plus the value of k again 1 by 10. And if you simplify it, then you will get P of capital X is greater than 4 is equals to 1 upon 5. Now the next problem, find the expected value and the variance of x for the following probability of mass function. The values of x are minus 2, minus 1, 0, 1, 2, and their respective probability 0.2, 0.3, 0.1, 0.15, 0.25. So we construct the following table to calculate the E of x and V of x. The values of x are capital X is equals to xi, minus 2, minus 1, 0, 1, 2. Okay. Pi is equals to their respective probability xi into pi, xi square into pi. Okay. And you will get here, see this, the table, their multiplications, and you can perform also this table. Now see this here. What is the summation of xi pi? That is equals to minus 0.05. And the summation of xi square into pi, that is equals to 2.25. What is the E of x? E of x is equals to summation of xi into pi. That is equals to minus 0.05. And what is the variance of x? The variance of x is a summation xi square into pi minus summation xi into pi bracket square. And that is equals to 2.25 minus in bracket minus 0.05 bracket square. Okay, if you perform its square, then you will get 2.25 minus 0.0025, and their subtraction, that is a 2.2475. Okay, therefore hence the E of x is a minus 0.05 and the variance of x is a 2.2475. Now the problem number 10. Find the expected value and the variance of x, where x is a number obtained on the uppermost face when a fair die is thrown. Okay, if a die is tossed, then the sample space for the random variable capital X is S is equals to 1, 2, 3, 4, 5, 6, and the P of x is equals to 1 upon 6, where the values of x are 1, 2, 3, 4, 5, 6. Okay, each have the equal probabilities, that is P of x is equals to 1 by 6. Then what is the E of x? That is summation xi into pi. P of x, that is 1 into 1 by 6 plus 2 into 1 by 6, 3 into 1 by 6, 4 into 1 by 6, 5 into 1 by 6 and 6 into 1 by 6. Take 1 by 6 as a common. Then in bracket you will get 1 plus 2 plus 3 plus 4 plus 5 plus 6. And their summation, that is a 21 upon 6, and that is equals to 7 by 2 is equals to 3.5. And hence the variance of x is equals to E of x square minus E of x bracket square. And if we substitute the values, that is a summation x belongs to capital S, x square into P of x minus 7 upon 2 bracket square. Now here we will calculate the probabilities. X square means what? 1 square, it's a probability 1 by 6 plus 2 square, it's probability 1 by 6 plus 3 square, it's a probability 1 by 6, and in this way calculating after this. Again last is a minus 7 upon 2 bracket square, that is 49 upon 4. And if we take 1 by 6 from all these common, then in bracket you will get 1 square, 2 square means 4, 3 square means 9, 4 square is a 16, 5 square is a 25, and 6 square is 36 minus 49 upon 4. And in this way you will get 91 upon 6 minus 49 upon 4. And if you calculate it, then you will get 182 minus 147 upon 12, and its calculation is 35 upon 12, and that's equals to 2.9167. And hence E of x is equals to 3.5 and the variance of x is equals to 2.9167. Next problem, find the mean number of the heads in the 3 tosses of a pair coin. Solution, when 3 coins are tossed, the sample space is, that you know from the 10th standard, that is n of x is equals to 8. Let x denote the number of the heads when 3 coins are tossed. That is the number of heads are 0 head, means all of them are tail, then 1 head, 2 head and 3 head. Okay, next the 0 head, that is the P of capital X is equals to 0. This happens 1 times, that is all are tail, and its probability is 1 by 8. Probability of capital X is equals to 1, that is the P of 1, that is 1 head is there, that is it's 3 by 8. 2 heads, then again it is a 3 by 8. 3 heads, then last is 1 by 8. And what is the mean? Mean means what? E of x, expected value of x, that is summation xi into P of xi, and their product, that is a 0 into 1 by 8, 1 head 3 by 1 into 3 by 8, 2 heads 3 into 3 by 8 plus 3 head 3 into 1 by 8, and after calculation you will get 0 plus 3 by 8 plus 6 by 8 plus 3 by 8, and overall you will get 12 upon 8, and that is equals to 1.5. Next, problem number 13. 2 dice are thrown simultaneously. If capital X denotes the number of the 6s, find the expected value of x, that is the E of x. When the 2 dice are thrown, the sample space S has 6 into 6, that is equals to 36 sample points. N of x is equals to 36. Let x denote the number of the 6s when the 2 dice are thrown. Then x can take the values 0, 6, 1, 6, 2, 6. Then when x is equals to 0, that is no 6 is there. These are the number of the sample points. N of x is equals to 25. You can count it. That is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. 3, 1, 3, 2, 3, 3, 3, 4. 3, 5. 4, 1, 4, 2, 4, 3, 4, 4. 4, 5. 5, 1, 5, 2, 5, 3, 5, 4 and 5, 5. No 6 is there. Therefore, n of x is equals to 25. Therefore, it's a probability. That is, no 6 is there. P of capital X is equals to 0. N of x upon n of s. That is a 25 upon 36. When 1 6 is there, that is capital X is equals to 1. X is equals to, in bracket, 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 6 1, 6 2, 6 3, 6 4, 6 5. N of x is equals to 10. Therefore, when capital X, P of capital X is equals to 1, n of x upon n of s. That is, the total is 10 upon 36. When there are the two 6's, this happens only the single time. Therefore, n of x is equals to 1. Therefore, P of capital X is equals to 2 is n of x upon n of s. And that is equals to 1 upon 36. And therefore, the E of x is equals to summation xi into pi. It's a definition, it's a formula. Then 0 6 is happening, its a probability is 25 upon 36. Next is next here the 1 6, it's happened 10 upon 36, it's a probability. 1 into 10 upon 36 plus 2 6's is 2 into 1 upon 36 and 0 into 25 upon 36 is 0. 1 into 10 upon 36, 10 upon 36, 2 upon 36 and their calculation, that is 12 upon 36 and that's equals to 1 upon 3. Two numbers are selected at random from the first 6 positive integers. Let x denote the larger of the two numbers. What is that? Two numbers are selected at random without the replacement from the first 6 positive integers. X denotes the larger of the two numbers. Okay. Then find A of x. The two numbers can choose from the first 6 positive integers. Therefore, n of x is equals to 6c2 and that is equals to, we will apply the formula NCR, that is a n factorial, here is a n factorial upon n minus r factorial into r factorial. By using this formula, you will get its value is a 15. Okay, let x denotes the number larger of the two numbers. Okay, then x can take the values. That is a 2 is greater than 1, 3 is greater than 2 numbers, 4 is greater than 3 numbers, 5 is greater than 4 numbers and 6 is greater than from the 5 numbers. That is when x is equals to 2. The other positive number which is less than 2 is 1. 1 is less than 2 and therefore n of x is equals to 1. This happens single time. Therefore, P of capital X is equals to 2 is a probability of 2, n of x upon n of s. This happens single time. N of x is 1, 1 upon 15. When x is equals to 3, the other positive number less than 3. Which are the numbers that are less than 3, 1 or 2? And hence, we can choose in the two ways. Therefore, n of x is equals to 2. Therefore, P of capital X is equals to 3 is a P of 3. And hence, n of x upon n of s, that is a 2 upon 15. Therefore, P of 3 is equals to 2 upon 15. Similarly, P of capital X is equals to 4 is P of 4. And that is a 3 upon 3, 3 upon 15. That is, there are the three numbers which are less than 4. It is a 3 upon 15. P of capital X is equals to 5. There are the 4 numbers which are less than 5. That is a 4 upon 15. There are the 5 numbers which are less than 6. Okay. And hence their E of x expected value. Summation xi into P of xi. That is a 2 into this happens 1 upon 15 times. The number which are less than 3, its a probability is a 2 upon 15. The number which are less than 4, that is a 4 into its happen 3 upon 15. Their probability is 5 into 4 upon 15, 6 into 5 upon 15. And after calculation, you can find out their LCM and calculate it. Then you get 70 upon 15. And therefore expected value is 14 upon 3. Now the next problem. Let capital X denotes the sum of the numbers obtained when the two fair dice are rolled. Find the standard deviation SD. We want to find out it. SD of X. If the two fair dice are rolled, then the sample space S of this experiment is that you know. Again, there is a 1, 1, 1, 2, 1, 3 up to the 6 is that you know. Therefore, n of x is equals to 36. Let x denotes the sum of the numbers on the uppermost faces. That is, if you take the first 10, you will get 1 plus 1, 2. There is a 3, 4, and in this way, that is, first is a, here is a 2, and the last will be, here is a 12. Okay. Therefore, the number of the sample point is 36. X denotes the sum of the numbers on the uppermost faces. Then x can take the values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the values of x. Now, the sum of the numbers, capital X, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then, the favorable events, the sum is 2 is 1, 1. Number of favorable cases is 1. Then its probability is 1 upon 36. Then next is the sum is 3. 1, 2, 2, 1 is 2, 2 upon 36. Sum is 4. Then 1, 3, 2, 2, 3, 1 is 3, 3 upon 36. And in this way, you will get their respective probabilities. 6, then 5 upon 36, 7, 6 upon 36, okay, 9, that is 4 upon 36, 10, 3 upon 36, 11, 2 upon 36, and in this way. The probability distribution of capital X is given by, in this way, okay. Therefore, the xi, that is the 2, 3, 4, 5, 6, and their respective probability. Therefore, the e of x, you can find out its e of x is equals to summation xi into p of xi. That is the 2 into 1 upon 36, 3 into 1 upon 36, 4 into 3 upon 36, and you can perform their calculations and take the 1 upon 36 as a common. Then in bracket overall, you will get 1 by 36 in bracket 2 plus 6 plus 12 plus 20 in this way. That is a 1 upon 36 into 256. After calculation, you will get their sum is a 252 into, here is a 36, and here that is equals to 7. Next is a also summation xi square into p of xi. Xi square means what? 2 square into 1 upon 36, 3 square into 2 upon 36, 4 square upon into 3 upon 36, and in this way you will get their calculations. Again, you can take 1 upon 36 as common, and then in bracket you will get 4, 18, 48, 100, 182, 94, 320, 324, and in this way. Okay, and therefore overall, if you take 1 by 36 common, then you will get 1974, and overall you will get 54.83, and hence the variance of x is summation xi square into p of xi minus e of x bracket square, and in this case you will get 54.83 minus 49, and hence the variance of x is 5.83, and hence its SD means root of p of x is equals to 5.83. Therefore, SD is equals to 2.41. Next problem. A class has 15 students whose ages are 14, 17, 15, 14, 21, 17, 19, 20, 16, 18, 20, 17, 16, 19, and 20 years. One student is selected in such a manner that each has the same chance, again I will repeat, each has the same chance of being chosen, and the age capital X of the selected student is recorded. What is the probability distribution of the random variable capital X? Find mean, variance, and the standard deviation of X. Let X denote the age of the student. Then X can take the values 14, 15, 16, 17, 18, 19, 20, 21. We can make frequency table to find the number of student with age X. That is age X. That is here are the ages. Next, tally marks. That is the equals to here. The two tallies are here. You can see these are the tally. That is the 14 age. There are the two persons, two students. Next, 15. Here is a 1. 16. Again, these are the two tallies. 17. Again, instead of 1, I am writing. This is the tally. There are the 3 students. 18 age. That is a single student is there. and 19, there are the 2 students, 20, and there are the 3 students, 21, and there is a single student, and total is a 15. The chances of any student selected is equally like. If there are m students with the age x, then the p of x is equals to m upon 35, and hence the p of capital X is equals to small x. The age of the student are 14, and their probability that 2 upon 15, 15, 1 upon 15, 16, 2 upon 15, 17, 3 upon 15, 18, 1 upon 15, 19, 2 upon 15, 20, 3 upon 15, 21, 1 upon 15. Now the mean E of x is equals to summation xi into P of xi. That is equals to 14 into 2 upon 15 plus 15 into 1 upon 15 plus 16 into 2 upon 15 plus 17 into 3 upon 15 plus 18 into 1 upon 15 plus 19 into 2 upon 15, their respective product of their respective probabilities. And next is a 20 plus 20 into 3 upon 15 plus 21 into 1 upon 15, and in this way you will get their mean. And after calculation you can take 1 upon 15 as a common, then 14 into 2, 28 plus 15, 16 into 2, 32, 17 into 3 is a 51, 18 into 1, 19 into 2, that is a 38, and the next is a 60 and plus 21, and in this way 1 upon 15 into 263, and that's after the calculation you will get here the 17.53. Now next is a E of xi square into P of xi. E of xi means what? Here 14 square. Here again their respective probabilities, which is the 2 upon 15. Here is a 2 upon 15. 15 square into 1 upon 15. 16 square into 2 upon 15. And in this way here you will get, that is a 15 square into 1 upon 15. 16 square into 2 upon 15. 17 square into 3 upon 15 plus next is a 18 square into 1 upon 15, 19 square into 2 upon 15, 20 square into 3 upon 15 plus 21 square into 1 upon 15, and in this way again take 1 upon 15 as a common. Then in bracket you will get, here is a 392 plus 225, 512 and 867 plus 324, 722, 1200 plus 44, and in this way there are the number of the numbers. Therefore their calculation is 1 upon 15 into 4683, and after calculation you will get 312.2. Therefore variance of x is E of xi square into P of xi minus E of x bracket square, that is equals to 312.2 minus 17.53 bracket square, and you will get, that is a 312.2 minus 307.3 is equals to 4.9, and hence the variance of x is 4.9. What is standard deviation? That is the root of variance of x, that is equals to root of 4.9, that is equals to 2.21. Hence the mean, that is a 17.53, and the variance is 4.9, and the standard deviation is a 2.21. And then last problem, in a meeting 70% of the members favors and 30 oppose a certain proposal. A member is selected at random, and we can take x is equals to 0 if he opposed, and x is equals to 1, he is in favor. Find E of x and the variance of x. Here x can take the values 0 and 1, favor and oppose. Okay. It is given that P of x is equals to 0, that is a P of 0, 30%, that is a 30 upon 100, which is 0.3, and 1, that is a P of 1, it's a 70%. Okay, that's we have given 70 upon 100, which is 0.7. Then what is the E of x? E of x is equals to summation xi into P of xi, which is 0 into 0.3 plus 1 into 0.7, and after calculation you will get, that is a 3 into 0.7 is a 0.3, and here again, sorry, here 3 into 0.3, that is a 0, plus 1 into 0.7, that is a 0.7 is here. Okay. Next also summation xi square into P of xi, that is a 0 into 0.3 plus 1 into 0.7. Again, this number will become 0 and you will get 0.7. Now the variance of x, summation xi square into p of xi minus summation of xi, sorry, e of xi bracket square, and hence here you will get, that is a 0.7, okay, 0.7 that we have calculated here. See this here, 0.7 minus 0.7, it's a bracket square that we have calculated here, e of x, the value of e of x, that is 0.7 minus 0.7 bracket square, that is equals to 0.7 minus 0.49, and hence the variance of x is equals to 0.21, and hence the e of x is equals to 0.7 and the variance of x is a 0.21, and in this way I have completed the first exercise 7.1. Now we'll see in the next video. Till then,